Okay then. Okay, I'm a fucking person of color. Yeah, man. La wea es que hemos estado 2 días, dos, o hasta diría que 3. Bueno, espero que solo uno, pero no lo sé. Hemos estado unos días sin, sexo anal. No, mentira, sin, probabilidad. So let's fucking go back to it, innit? Let's fucking go back to it. There you fucking go. Yeah. Ok, y ya por mano, esa wea vamos a seguir con Chetumari. Vamos a seguir porque pues eso, ¿no? Ni siquiera me acuerdo en qué estaba. Ni siquiera me acuerdo en qué estaba. Ah, ya. Ok, tenemos como un librito que leer. En it. ¿Por qué aquí tengo esta wea? Ah, esta es Introduction to Linear Algebra. So fuck that nigga. Solo tenemos ahora esto. Ya, page 22 and shit. Bitch ass nigga. Bitch ass nigga. What else? Dark web, what the fuck? Okay. So yeah. Let's go back to it. Let's go fucking back to it. Yeah. Alright. Cool. Let me just put a title again. Probability. Stuck it stinks my stain. Stuck in the pinch my stain. Ah shit, my bad, nigga. I saw you asking now about normalization. Yes, measure theory something. Okay, what did I ask? Oh yeah, when does it happen? I like this music. Oh, beautiful. That's when it happened. Round weights or scores. Video game loot. What? Loot table. Game files may say common sword. Rare shield. Interesting. Okay. So we got 85 and then we have 15 for something else. To fix this, you normalize them by dividing every single weight by the sum 85. Gotcha. Got it. The math still works to show relative livelihoods. It's 10 times more likely than the helmet. Yeah. Now they add to exactly one. Normalization uses the final conversion step to turn around messy real world data into the strict 0 to 1 scale. The probability axioms man. Limit theorems to the fucking bar curve. Is that what it said, right? So limit theorems just a fucking bitches nigga. Come pretty much streaming, right the pinch the man ringing, ring the pinch the man ringing.
Hello everyone, I'm Akash.
Motherfucking nigga. Discrete probability law. What it did. 12 minutes, man. Introduction to discrete. Yeah, let me see this video. Sure, why not? Skrat de prastige merinis. Stukret de prastige gaslinkering. Hardigens de barteritres. Ratiker de parsritus. Stakker de piste borstpistis. Roeit pas de pessimistis. Prestigas de monstistis. Ratikas de monstistis. Stinsis. What do we think? Integer probability. Oh, this motherfucker, man. This motherfucker actually sells courses, or you're teaching something? I don't know. Probability, top term, how Russia tried to learn Rust. Oh, this nigga. Don't leave yourself exposed. Seems fun. Learning software engineering during the AI, the era of AI. How long is this? 12 minutes. We might see this. We might see this. Latex? What the fuck is latex, bro? I'm going to browse anonymously in 2026. Look at that. Okay, come on, brother. You don't know how to do that. You know how to do that. Okay. It's correct practical things. Correct medical things. Just briefly to summarize the central limit theorem, CLT, which is absolutely crown jewel. Here's why it's practically magic. The word is ugliest nigga, most chaotic nigga probability distribution in the universe. It doesn't matter if it's shaped like a square, escape or ramp, or a completely random jackknife. Really? If you run that experiment over and over, take the average of your results and plot those averages. What? That's interesting. The universe forces it into a fucking bell curve every single time. What? So the central limit theorem is like average of all the averages? Bell curve. Hold on. Let me answer exactly what you said. The mathematical proof that when you zoom out to infinity, the chaos smooths itself out into a highly predictable, mathematically beautiful normal distribution, the bell curve. What? To infinity. It is the only reason statistics actually works in the real world. Sounds like it reminds me of the. It reminds me of the wisdom of the crowds. You just need to understand the word discrete. Discrete means chunky, incantable, and separate. It is the exact opposite of continuous, which is smooth, infinity measured. The number of people in a room rolling a die, flipping a coin, you can have 2 people or 3 people, but you can have 2,000. What? Why not? Oh, I can have 2.718 people, but I can have 2,000. Yeah. Okay. So discrete just means like números enteros. Exact temperature inside, exact weight of an apple, it can be continuous. Discrete probability law often. Discrete probability law. So an event, right? Over 6, 1/6. Remember these were the calculus 9 where it begins. The script probably just contains solid. Maybe that things was Lambda, Lambon, Poisson distribution, probability mass. Variables exactly equal to some value. The Poisson distribution is a discrete probability distribution. Okay. Constant mean rate independently of times is the last event. Gotcha. It's the number of. Just the number of. This is the time, right? No. Number of occurrences of an event is a discrete variable. I mean, it cannot take an integer, but yeah. Probability of observing exactly. The likelihood. Legend. A ver, esto es como parece una ola, ¿no? Como... Fuck, no sé cómo explicarlo. O sea, solo es uno, empieza fuerte pero muere más rápido. Este también empieza en 20, o bueno, crece más o menos rápido y muere. Este crece lento y crece poco, pero dura más. Distribution for larger, okay. Interesting. So we are here. Additivity axiom. What was the additivity action about? So the probabilities of its elements. Yeah. But this is when they don't repeat. No, I mean when they can. Yeah, when the order doesn't matter. All right. Okay. The sample space consists of finite numbers of possible. Oh my goodness. Single element, yep. Is the sum of the probabilities of its elements. Of any element. Okay, yeah. Note that we are using here the simple notation P is, yeah, solo número. It's como N. It's like saying N. Hold on. To know the probability. Instead of the more precise P. What? ¿Qué fue con mi ojo? Puta madre, hermano. Ya suena, weón. Carajo. Aña comienza. I don't know what the fuck you mean, man. Okay, we're gonna use at maximum only 3 images, no more. In one single prompt. This convention will be used throughout the remainder of the book. This convention? What the fuck do you mean? Like this? My bad. Don't use this image. Sign by necessity equal to 1 and view the normalization action. Normalization action. We obtain the following. Discrete uniform probability law. Oh my god. If the sample space consists of n possible outcomes which are equally likely. Wait, okay, hold on. Hold the fucking on. Onta el video, weón. No hay video, maño. Este es el video. Ah, ya vi un poquitito.
The following
50 minutos, no me acuerdo.
Some are extremely
Este es Bro, I haven't seen this shit. Yo,
angry.
wait,
The same
wait.
goes for pretty
I haven't seen this
much
shit.
any other
I saw a few minutes about
formulas, but here because
saw from a few minutes
And
of this. I remember.
what
I
are the
remember.
basic rules of the game for dealing
Basic
with
rules.
probabilistic models?
Such a cool guy, man.
So by the end of this lecture, you will have
This motherfucker. What
essentially
the fuck you?
recovered
What the
half
fuck
of
you doing? Stand up.
this semester.
Standing up. The fuck you doing walking in my classroom, nigga? It's a sample space consists of n possible outcomes which are equally likely, i.e. on single element events have the same probability. Yeah, okay. Yeah. Then the probability of an event A is given by, for sure, for fucking sure, yeah. Wait, number of elements of n. What is n? Possible outcomes which are, yeah. Number of elements. Hold on. What do you mean number of elements of A? Pero no se supone que A es solo uno. An event A is given by. Pero bueno, entiendo que sí, claro. Si me hablas de un resultado, de todas las posibilidades que hay, pues dividimos simplemente el resultado de mierda, que pueden ser varios elementos, me parece, dentro de entre n. Está bien, vamos a let's make fucking sure, bro. So here, even though A can have many elements, it's just like one result divided by every possible outcome, right? Nice. Let's provide a few more examples of sample spaces and probability laws. Probability dodge. Consider an experiment involving a pair of four-sided dice. Figure 1.4. Where's that? This one, right? Okay. What is this, dice? No way. Four-sided dice. Chucha. ¿Cómo es eso? Sería como una pirámide. Una pirámide. Right? Four-sided dice. Yeah, fucking pyramid. Tetrahedral. But what the fuck is this? Are fair shouldn't be is fair. Interpret this assumption to mean that each of the 16 possible outcomes. Oh yeah, because we have two dice. Okay. Oh yeah, definitely, bro. That's what you mean by A. Yeah. The first row is equal to the second. Oh, on in. The first row. O sea, si tienes un 2 y un 4 y después tiras de nuevo y tienes un 2 y un 4. Oh, no. Is that what you mean? Or you mean like the first die is the same as the second one die? I think. Bennett. At least one roll is equal to 4? Oh. Okay. Pero no entiende. Ah, bueno, es que solo tenemos 4 números. Pero igual no creo que sea 4, weón. ¿Cómo chucha va a ser? No creo, weón. Y además, no, mierda. Solo. God. Yeah, I think you mean. Yeah. I think you mean the die, no the roll. Yeah, definitely, bro. Definitely. Yeah. Okay. Larger than the second. Yeah, just a few numbers. Wait. Bro, what the fuck? Oh, yeah. Yeah, 6 sounds fair. At least one roll is equal to 4. Okay, let me count that. Okay, claro, porque tenemos 4 y también puedo usar 4. Ahí ya tenemos 5 y en el otro también 3 más. Wait, why 3 more, bro? The fuck are you talking about? ¿No sería 8, weón? Yeah, right. Ah, bueno, porque dice at least. Si los dos son, pues ya se cumplió cuando uno tiene 1. Cuando uno ha tirado 4. Yeah, cool, right? Sample space for pair of rolls. The first roll is equal to the second. What is this fucking shade? This one roll is a 4. Probability, yeah. Oh, look at that. The first one is equal to the second. Yeah, wow. It's pretty fucking cool, man. Various events of the experiment of rolling a pair of 4-sided dice and the probabilities calculated according to discrete. Wait, oh yeah, this is 1 point. What the fuck? Oh yeah. Okay. Continuous models. Probabilistic models where continuous sample spaces differ from their discrete counterparts in their probabilities. In that, the probabilities with a single element events may not be sufficient to characterize a probability law. This is illustrated in the following examples, which also indicate how to generalize the uniform probability law to the case of a continuous sample space. Say that again. Fuck you. Probabilistic models with continuous sample spaces.
In today's talk, we are going to see what is countable set. So let's begin. A set S is said to be countable if it is either finite or countably infinite.
Infinite? What? Oh, countably infinite.
So what is finite set? A set S is said to be finite if it is either empty, that is, it has no element at all, or it has n number of elements for some n belongs to set of natural numbers. What is countably infinite set? A set S is said to be countably infinite if there exists a bijection
You don't say infinite, bro. Infinite.
of n onto S. That is, if there exists a mapping F from set of natural numbers to S, which is bijective. That is 1, 1 and only.
Bijective. It's not BG, right? Bike. No, my nigga, what the fuck? Baljit. Baljit. Okay. Baljit.
Map. That is, if there exists a one-to-one correspondence between the elements of natural numbers and elements of S. In the next part of this short, we will see the examples of countable set. Thank you for watching. Hello everyone, I am Akash. In today's short, we are going to see what is countable set. So let's begin. A set S is said to be countable if it is.
Hola. Bueno. Esto parece Snowden. Oh my fucking god. 27 minutes, bro. How do they even get to this neon boards? That's so fucking cool. Continuous probability distributions, basic introduction. Everything is a fucking introduction right now. Okay, let me see.
Let's say we have a random variable x, which can take any value between 0 and 10. When an event occurs according to the probability
the fuck is that, man?
distribution of x, we refer to this as sampling from x. Here's what we call the probability density function of x, which basically tells us the probability of a sample being any of the values between 0 and 10. An interesting quantity describing the distribution of x is its expectation.
The bell curve or the limit. What the fuck is this? Central limit theorem. Is that what you're talking about?
It is basically the average value that you can expect when sampling from x, and it can be computed using the integral.
Oh, look at that!
Of the probability density.
The integral of the probability
function.
density function.
Now let's consider two random variables,
Why?
x and z. What you see here in 3D is what we
look at this bullshit.
call the joint probability distribution of x and z. This represents the probability of each possible pair of events.
What is bijective? What is bijective? Okay, that was my original question. Bijective. Look at that. Actually here. Quaternary blocks, man. Okay. No, my nigga, no.
Say we have a random joint probability distribution of x and z. This represents the probability of each possible pair of events occurring together. Of course, each variable also has its own individual probability distribution, known as the marginal distribution. An interesting property of the joint distribution is that we can use it to compute each of the marginal distributions.
Only by having this. What is marginal
This
distribution?
process, known as marginalization, involves integrating the joint distribution
integrating the joint distribution
with respect to the other variable.
What is
For
the other variable? This, right?
Example, to find the probability of sampling a specific value according to x.
Look at that. Wow.
We integrate the joint distribution over all possible values of z.
Wow.
Let's say we have a random variable.
That's what the fuck. That's what the fuck. Best bit I probably most machines for discrete data. That's what the fuck, man. Like for real. Come on, bro. What the fuck you doing? Come on. No me mires así, che tu madre. Stochastic runners create a distribution curve. These motherfuckers. Yeah, I guess. Yo, this thing looks so crazy, man. What the fuck? Este es el típico comentario del Squidward, de Calamardo, weón. Calamardo loco. Make decisions, deterministic models. Mark of James. Yeah. Okay. I don't know, man. Oh yeah. I wanted to see this. Okay. Then objective. Yeah. Yeah. Let's see what you got. What you got to tell me. Am I multitasking like a motherfucker? I don't know. Is this a good way to learn? I don't know. It's absolutely beautiful. And it is honestly one of the best ways to think about it. You're connecting the math to the real world. I know, I'm a genius. I know, I'm a fucking idiot. I know that. Exactly what these concepts mean. Step by step. Essential limit there. And the wisdom of the crowds. Basically. Mathematic version of the wisdom of the crowds. Yeah, right. Yeah, we are. Yeah, I know, dude, motherfucker. Find the average guess for each group. Oh, 1,000 groups of people. Yeah, that's what I'm talking about. Then plus those 1,000 averages. Those averages were perfectly stacked up. Wow. Dead center. That's insane. A radical bias when you average the averages. The counts constants. What? Wow, that's crazy, man. Probability distribution is this, right? I guess. Master list, a map, or a graph. Huh. How long is each alchemist distribution? 5% or 45%. Coin toss. Where the fuck is my cell phone, man? Oh, there. Oh my goodness. Skrenny Penstigonstenis, Skrenny Penstigonstenis, Skrenny Penstigonstenis, Raketa Premstamonstenis. That's some of my Russian rap, you know what I'm saying? Rolling 2 dice. Yeah, but what's the graph? What is the this, you know, the map or whatever? The map that goes right from 2 to 12. Yeah. Like a pyramid. It's most likely outcome. True, I guess, because there are many ways to make Yerp. Very unlikely. Only 1 on 1. Yeah, man. Grading a test. A teacher might look at the distribution of test scores. The bulk of the class might get around 80, with a few students getting 100s and 50s. I gotta study physics again, bro. Somehow, I gotta fucking do it. Don't you think? Let's create numerous enteros. Spot on! Probability usually. Yeah, integers. My bad. It's just called integers. Yeah, just call integers. Yeah, it's just call integers. Thank you. Thanks, Lord. It is for things you can count. Sure. You're gonna have, yeah. You're gonna roll 3.14. What is chunky, bro? You can't repeat that shit. What the fuck is chunky? Minecraft plugin. Oh, it's a plugin. Oh, got it. Short and thick. Very cool. Continuous thick pieces. Chunk bitch. Separate numbers. You can just make it simple. What? You can just make a simple table to list your probabilities. Time. Wow. Temperatures. Imagine trying to calculate. So probably the buzzer eyes. Wow! Can I really do that shit, bro? Yo. I want to do that, nigga. Because time's continuous. The buzz get it right back. Get it right back. Take it the time. Yo. Zero, what the fuck? Yeah. The area under that curve. Yeah, I know this shit. I don't want to forget it though. That is the continuous probability law. Instead of just doing basic addition like you do with discrete whole numbers, you use integrals. Cool, man. To sum up an infinite number of infinite thin slices. That's so fucking cool. Okay, so let's keep going with this. Actually, let me watch this video.
We've already spent some time looking at random variables and defining random variables in different ways. And the one that I keep alluding to, maybe because it's one of the simplest definitions of a random variable, is one that's derived from a coin flip, maps the outcomes of a coin flip to some numbers, to a random variable. And so we could say that the random variable is equal to 1, or let's say it's equal to 0 if we get tails on my coin. And let's say if it's equal to 1 if I get heads on my coin. Now, the one thing that this random variable definition is not doing for us so far is telling us the probability of getting our random variable to be 0 or 1. And to get that information, we need something called a probability distribution. Probability distribution for this random variable.
Okay.
Essentially tells us the probability that we get any one of these outcomes. Now, is this a discrete or a continuous random variable?
Discrete. Must be fucking discrete.
Well, the outcomes here are distinct. They are countable. You could list them. This is definitely a discrete random variable. So we will construct, or we will be taking a look at, a discrete probability distribution.
Yeah.
Discrete probability distribution. So let's say someone says,
okay, and then you're going to show me, yeah, this one. Exactly, this fucking one.
Okay, I've defined this random variable in some way for a given coin, and I'm going to give you the probability distribution. And so they come here and they start drawing this probability distribution. And most probability distributions, they tend to be depicted visually. And so here in the horizontal axis...
Wait, so you're telling me sometimes not depicted visually? How could that be?
I will plot... all of the possible outcomes. So you can view this as kind of the outcomes for my random variable x. So the outcomes are either I'm going to get a 0 or 1. So 0 or 1. There's no other outcomes. I guess you could list other outcomes and just say they have a 0 probability of happening, but these are the ones that can actually happen. And then here on the vertical axis, I'll plot the probability of getting any one of those outcomes.
Which
and
is
so
0
the person
and
tells
100.
you, okay, the probability of getting a 0 is 50%. 50%. So they draw a little bar here. It's like a histogram, a bar chart. And so this goes right up here to 50%, which I'll draw as a decimal, 0.5.
Yeah, man.
And they tell you the probability of getting a 1, of the random variable becoming a 1, is 60%. 60%.
60%? What the fuck are you talking about?
Let me draw it just like that. 60% or 0.6. Now my question to you, and I know you're just starting to be exposed to probability distributions, but based on what you know about probability, is this a legitimate probability distribution?
Not at all.
Well, let's think about what the probability of all of getting any one of.
Is this part of a playlist or something? Because no way, bro. Shut up. What is PSA? That sounds so cool. That sounds so cool. I want to see these betas, bro, but there's no part of the fucking course, you know. This ain't part of the fucking course. Raymond Mafu.
Honey.
Nah, shut your bitches up. Honey.
Of these outcomes. So let's think about the probability that our random variable is equal to 0, or we're doing a union.
Or is union.
Yeah,
or is union. Right? Because claro, porque estamos sumando todo, porque vale con que sea solo 1. Si es and, it's different. That's overlap.
And or the probability that our random variable is equal to 1. These are all of the possible outcomes. We're essentially saying, what's the probability that we get one of the possible outcomes for our random variable?
Yeah, 100%.
Well, over here, we would just add the two probabilities. So the probability of this one right over here is 0.5. And then we're taking a union. And these are mutually exclusive events. So we can just add the two together. And then we have the probability of getting a 1. The probability of getting a 1 is 0.6. Actually, let me do that in a different color. Do it in blue. The blue is 0.6. And this strangely adds up to 1.1. Somehow saying that you have 110% probability of getting any of the possible outcomes. This makes absolutely no sense. You cannot have a greater than 100% chance of having any one of the outcomes. If you're looking at all of the outcomes from a random variable, it should add up to 100%. So you point this out to the gentleman who's trying to tell you that this coin is defined in this way, or the probabilities are, and he says, oh, yes, I made a mistake. That was not the probability distribution. And this right over here is not 0.5, 0.5. Let me clear it. Actually, let me clear this and redraw it. So he realizes that this was actually 0.4. 0.4. And now my question again to you is this: does this at least look like a legitimate probability distribution?
It looks, but
well, sure. The sums of the exclusive outcomes that this random variable can take on now equal to 1, 0.6, 0.4. And now the last thing I'll ask you, given what you know about this random variable, it's clearly an unfair coin. Are you more likely to get heads or tails? Well, the random variable, you're clearly more likely to get an outcome of 1. If you look at the definition of a random variable, the random variable will be 1 when your coin is heads. So it's clearly somehow the coin is weighted a little bit more probable to having heads. So I'll leave you there. In the next few videos, we'll study more and more probability distributions, which is really the core of probability, and we see it becomes a very helpful thing when we start to study inferential statistics.
Oh, that's inferential statistics.
We already
Normal, uniform. Wow, exponential, decay pattern. Everywhere. Binomial. What do you mean? Poisson. Poisson es que como que va bajando, ¿no? Event rate, 3 per what? Beta. I'm an alpha, you know what I'm saying? I don't know. Difference between Poisson and beta. Coñaco. Differences between Poisson, binomial, and beta distribution. Normal heights, IQ? Oh, yeah. Uniform random choice. But like real random choice, I guess. Wait times for what? Success failure. Wow. Poisson relevance, beta probabilities. Okay, whatever. Continuous models. What we got after this? Afterwards. Nice. Probabilistic models with continuous sample spaces differ from their discrete counterparts in that the probabilities of a single element events might not be sufficient to characterize the probability law. Which also indicate Oh, in the interval 0 to 1, it is appropriate to consider outcomes. Hold on, bro. Hold on, brother. Okay, first let me see it. Oh, okay. Consistent of a single element. What do you mean by a single element? Cannot be positive because then using the additivity axiom, what the fuck? It will follow that events with a sufficient large number of elements will have probability larger than 1. I don't know what you're talking about. Therefore, the probability of any event that consists of a single element must be 0. What the fuck? I don't know what you're talking about. Oh, mierda. I mean, yeah, I think just by looking at the video I will understand better. But it's good to have this dab right now. Oh, because cualquier número, any number greater than 0, but between 0 and 1 is gonna be just 0.1, 0.0001, 0. Bitch ass nigga, fuck ass nigga in the hood, and all that. I think, right? Is it because I think so. It makes sense to say probability B minus 1 to any subintervals. A, B. Show one to calculate the probability of one complicated set by evaluating its length. Got it. Okay. This is still a continuous model, right? Properties. Good. Romeo and Juliet are two motherfuckers. Have a date at the given time. And each will have a meeting place with a delay between 0 and 1 hour. Hola, que tardón, without pairs of delays being equally likely. Wow. Wow. What does it mean? Que si uno llega 15 minutos después el otro también. Porque. No sé. Porque no importa. Que no importa qué tan tarde, sino puede llegar en cualquier momento. Y en cualquier momento tiene la misma probabilidad de llegar tarde. De llegar tan tarde. ¡Wow! ¡Wow! ¡Qué buen ejercicio! Y ahora, si esto pasa en la vida real, qué locura también, ¿no? What is the probability that they will meet? ¡Wow! Bueno, si llegas acá, muy gracioso, la verdad. ¡Wow! ¡Qué locura! Those sample space. Claro, aquí usamos geometry, right? Or calculus. Yeah. 7/17. No, 7/16. How do you know that? Ok. Claro. Un cuarto. What the fuck is this? A ver, esto es such as that, la probabilidad de que de que pase esto, such as ¿Qué significa esto, weón? This is multiply. O de que pues, en cualquier momento. X and Y. It is X. No, bro. How do we even read this? This is cool though. So fucking cool. Yeah. You're getting the same yeah. Brush tracking model. This sounds interesting as well. Okay. Between everything is data, bro. Everything is fucking data. That's absolutely beautiful. Difference is pure, unadulterated mathematics laziness. Yeah, what is that? When we establish that the probability function P acts like a machine, well, it's a drip of water. Probability machine only measures buckets, so we get a fucking bucket with only a drop of water. That's cool. You put the outcome water into said bracket, the back of the machine waits it from a little and choose the naked water drop. Where this outcome sometimes lying. So, really? Everyone universally agreed in a shortcut. Oh, that's so crazy, man. That's cool. One result. Is the total count of results you care about divided by the total count of possible? Oh yeah, I care about. Yeah. The keyword here is uniform. Right. Let's say your experiment is running a fair die. Yeah. Die, bitch, die. Let event event A be rolling a number larger than 4. Yeah. So the number of elements is 2. The map probability of fate 2 over 6 or 33.2%. Reaction to the continuous probability is completely accurate, bro. Are you making fun of me, nigga? To calculate exactly millisecond is impossible. Really? Well, yeah, millisecond. We don't care about that. I don't think it's impossible. I mean, at least no, of course, not a 100%, but you can get a fucking percentage, right? Yeah, let me ask you about that. Wow, that's crazy. A bucket. You're right, a bucket. As long as 0 is under there, is there under the curve. If you actually wanted to build this model, here's the data you would need to collect. Historical data, yeah. Thousands of past records of when those actually arrive. Traffic data. Historic speed limits, congestion, stoplight timings. That's so cool. Environmental factors in raining, yeah. Tuesday or Sunday, yeah. How would you do it? You would take all those arrival, pass arrival. Buckets. What about once you plug in the historical data of the chart? Wow. 42% chance is kind of big, right? Have you learned about condition probability yet? Did I? I don't know. Oh, not yet. Hold on, bro. Hold on. The condition that it just started snowing. Wow. Okay. I'll be right back, fellas. Fox. Thanks, central limit theorem. Wow. Okay. Okay, that's it for today. Love you, niggas.